We're on problem 27, and they tell us if I is equal to the square root of minus 1, then what is 4 times I, that's an I, times 6 times I? Well, multiplication's associative. You can switch the order around. So this is the same thing as 4 times 6 times I, or the same thing as 24 times I squared, right? And if we square both sides of this, you get I squared is equal to negative 1. I squared is equal to negative 1. So this is 24 times negative 1. So it's minus 24, which is choice C. Next problem, 28. They want to know what an equivalent form of 3 plus I is. And a lot of times people don't like either when you have a square root in the denominator, or they don't like it when you have a complex number in the denominator. A complex number is just something that has part real and part imaginary, right? So the way you can do it with this case is you multiply times the conjugate of this number. And I know that sounds like a fancy word, but all it means is you take the opposite of the imaginary part. So what's the conjugate? So you want to multiply this times, and remember, the only way you can not change a fraction is if you multiply the numerator and the denominator by the same thing, because then you're multiplying by 1. So what's the conjugate of this? The conjugate of 3 plus I is 3 minus I. 3 minus I. And you have to do it 3 minus I over 3 minus I. Right? And I'm doing that because when you multiply a complex number by its conjugate, you end up actually with a real number. And then you're going to end up with a complex number up here. And a conjugate, all it means is you keep the real part the same, and you change the sign on the imaginary part. That's all that word means. All right, now let's figure out what this is equal to. 2 times 3, just same distributive property as always. Let me do it in green. 2 times 3 is 6. 2 times minus I is minus 2I. All of that over. See, 3 times 3 is 9. 3 times minus I is minus 3I. I times 3 is plus 3I. And then I times minus I, you could view that as minus I squared. Right? And let's think about what this is equal to. Well, this plus 3I and the minus 3I cancel out. And what's I squared? Well, this is equal to negative 1. So you end up with a minus of a negative 1. Right? And minus of a negative 1 is plus 1. So you're left with 6 minus 2I over 9 plus 1 over 10. And actually, we can reduce this sum. We can divide the top and the bottom by 2. So that becomes 3 minus I over 5. Just divided both numerator and denominator by 2. And that is choice B. Choice B. Problem 29. These go fast. 29. No systems of equations and all of that. What is the product of the complex numbers? 3 plus I and 3 minus I. They just asked us that. That was in the last problem. When we multiplied 3 plus I times 3 minus I, what did we get? We got 10. We did this whole thing. 3 times 3 is 9. We did the whole thing. So they're just repeating the same question. That equals 10. That's choice B. Rewind the video and see what I did here. 3 times 3 is 9 times minus 3I plus 3I minus I squared. These terms cancel out. You get a minus I squared, which is minus negative 1. So you have 9 plus 1. So it equals 10. So that is choice B. That's crazy. They just gave us the same problem twice in a row. Let's see. All right, they're giving us more and more imaginary problems, but these are fun, especially if they're going to repeat the same question. Problem 30. If I is equal to the square root of negative 1, well, I'll just keep writing it because they keep writing it. It's good as a reminder. I is equal to the square root of negative 1. And A and B are non-zero real numbers. What is 1 over A plus BI? Well, once again, if they kind of want us to rewrite this, they probably just want us to get rid of the i's in the denominator. So we multiply times the conjugate of this complex number. So we multiply times A plus BI, the conjugate over the conjugate, right? A plus BI. The conjugate isn't this whole thing. The conjugate is just A plus BI. Oh, sorry. We should be multiplying times A minus BI. A minus BI over A minus bi. And the conjugate of a plus bi, just so you get the terminology right, is just the a minus bi. But I'm doing a minus bi over a minus bi, so I'm not changing this fraction, because this obviously is 1. X over x is the same thing as 1. So let's see what this is equal to. Well, the numerator just becomes a minus bi times 1, which is a minus bi. Then you have a times a, which is a squared. A times minus bi, so it's minus abi. Then you have bi times a, which is plus abi. I'll write it down here, plus abi, and they cancel out. And then you have bi times minus bi. So that's minus b squared I squared, right? So let's see, these cancel out, and so you're left with a minus bi over a squared minus b squared I squared. But we know what I squared is. I squared is equal to negative 1, right? You square both sides of that, you get I squared is equal to negative 1. So this is the same. So if we multiply, this becomes a negative 1. But then this negative and a negative, they cancel out. You get a plus. So then we get a minus bi over a squared plus b squared. And that is choice B. Choice B. Next problem. Okay. All right, what are the solutions to the equation? X squared plus 2x plus 2. All right, now if you see an equation like this and you're like, okay, let's see, can I factor it? And that is equal to 0. You say, okay, what numbers when I multiply them equal 2, and when I add them equal 2? Well, that's a hard one. And whenever you get stuck, the easiest thing to do is just use the quadratic equation, right? And just as a reminder, if you have the problem, if the equation is ax squared plus bx plus c, maybe I should have done them all in capital letters, is equal to 0. The solution to this, and the proof of this we've done in the Khan Academy, it comes from completing the square, but it's useful to memorize, is negative b. So the solutions are x are equal to negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. So in this case, what is a? A is the coefficient on x squared, so a is equal to 1. What is b? B is the coefficient on x, so b is equal to 2. And what is c? C is just a constant term, so c is equal to 2. And we could just solve like that. Just substitute these values. So you get x. So you get x is equal to minus b, which is minus 2, plus or minus the square root of b squared, so that's 4, minus 4 minus a, so 4 minus 4 times a, 4 times 1 times 2, all of that, that's an ugly looking radical, all of that over 2a. 2 times 1 is 2. So that equals, let's see, we get minus 2 plus or minus the square root of 4 minus, this is 8, right? 4 times 1 times 2. 4 minus 8, which is minus 4, all of that over 2, which is equal to minus 2 plus or minus. So the square root of minus 4, we could rewrite that as the square root of 4 times minus 1, right? So that equals 2 plus or minus the square root of 4 times the square root of minus 1, all of that over 2, which is equal to minus 2 plus or minus, square root of 4 is 2, and the plus or minus carries, so it's dealing with positive or negative 2, times the square root of negative 1. Well, we learned that's I multiple times. Square root of negative 1 is I. All of that over 2. And we could simplify this a little bit. I'll do it in a different color just because I've run out of space at the bottom here. So this is equal to, divide everything by 2, you get negative 1 plus or minus I. And let's see. The choices are, right, that's choice C, because negative 1 plus or minus I could also be written as negative 1 plus I as one value for x. And then the other one would be negative 1 minus I. And they separate it out. They don't write plus or minus in the actual problem. And I'm out of time. I'll see you in the next video.